Well, good day to you. I'm working on podcast number 20. How do I integrate natural log of x over the square root of x? Well, if that square root wasn't there, I would say let u equal the natural log. The derivative of that is 1 over x, but it's got a square root, so that's not really going to help. Then what about integration by parts? And then you say integration by parts, hey, you're supposed to be having two things that multiply. And then I say, yes, we do. We have a natural log of x that is being multiplied with a 1 over the square root of x. So I can use integration by parts. Now when you do integration by parts, the u should be chosen so its derivative makes the problem simpler. If I choose this as the u, then the derivative of that is still going to have a square root in it, which does not make life simpler. If I choose this to be the u, the derivative is just 1 over x, and that's actually simpler than trying to integrate natural log of x. So this will be the u. Let u equal the natural log of x. This will be the dv, so let dv equal, and then I'm going to need to integrate, so I'm just going to go ahead and rewrite this as x to a negative 1/2. All right, over here, take the derivative. That will be 1 over x dx. And over here, integrate. So add 1 to the exponent, which becomes a 1/2, and divide by 1/2. So v equals, when you divide by a half, that means invert and multiply, so it's going to be 2, and then x to the positive 1/2 exponent right here. All right, then multiply on this diagonal. So for this one, I'm just going to go ahead and rewrite it because this is going to be in the final answer, so I might as well rewrite this as the square root of x. So there's going to be 2 times the square root of x, and then times the natural log of x, minus the integral, and then multiply the bottom row. So there's going to be 2 times x to the half, and then times 1 over x dx. And now it looks like this one isn't too bad at all. So right here, I can simplify. So this is an exponent of 1 on this guy, and if you're dividing, then you subtract the exponents. So let me just copy this down real quick so I don't forget it. 2 square root of x, natural log of x, minus the integral. And then this 2, I could factor it out. And when you subtract a half minus 1, that's going to leave x to the negative 1/2. And believe it or not, we're almost done. We're only at 3 minutes and 17 seconds. So add 1 to the exponent, that's going to be a half, and then divide by that half. So this is still a part of the answer, 2 square root of x times natural log of x. When you invert and multiply, this becomes a 2 times that 2 makes 4. And then this part right here becomes x to the half, so that means square root of x. All right, we're done with the antiderivative part. Then don't forget, it's from 0 to 1. So evaluate from 0 to 1. So when you substitute a 1, this is going to be the square root of 1, which is 1. So 2 times 1, and then natural log of 0, excuse me, we're plugging the 1. I was saying the answer instead of the question. Natural log of 1 equals 0. Here, let me show all of my work. So 2 square root of 1 times natural log of 1 minus 4, and then square root of x, so square root of 1. And then minus, now substitute the 0. So this is going to be 2 times the square root of 0, and then the natural log of 0, and then minus 4 times the square root of 0. So natural log of 1 is 0, so this part is gone. This is just a 4. This is a 0. That part's gone. So all we have so far is negative 4 times 1, and then minus, what is this part? The square root of 0 is 0, but natural log of 0 is negative infinity. So what does this equal? Because if this is negative infinity, so the natural log function looks like this. And if you get closer and closer to 0, then this is going down to negative infinity. So if this is a 0 times a negative infinity, what does that equal? Well, basically, if you put x's back, we basically have 2 times the square root of x, times the natural log of x, and it's the limit as x is going to 0. And technically I should have put the right side because it's undefined on the left side. So technically on the 0 I should have had a little plus sign. Well, I don't know if you can tell, but I just took a little break because I had to go get a calculator. Because looking at this one, finding its limit seems like it's going to be pretty challenging. So let's use a calculator and find out what's going on. So taking a look at this function, the 2 square root of x, natural log of x, and then take a look at the graph. And because they're close to 0, I do have the window, so the x's are pretty close to 0. And then if you look at the graph, it seems like that looks like it's y is a negative 1. But if you trace and plug in a number very close to 0, does the answer equal negative 1? Right now that equals a 0.184. But if you pick something even closer to 0, then that is now a negative 0.028. And if I pick something even closer to 0, that is now a negative 0.004. So the graph actually looks like this. And so as you get closer and closer to 0, the y value is 0. Okay, so to finish this one up, this question mark turns out to be a 0. So the final answer is a negative 4, and a negative 0 makes a negative 4.